Okay, hello everyone. Welcome to actually Zero Density R&D Studio. This is our first webinar that we do from our green screen studio, and we are very excited. Thank you for being part of it. So first of all, let's talk a bit about ourselves. Zero Density offers the next level of virtual production with real-time visual effects. It provides Unreal Engine native platform Reality Engine with advanced real-time compositing tools. Reality supports industry-standard mechanical and optical tracking systems, and with these tracking webinar series, we'll talk about technology, reality integration, and projects. My name is Birim. I'm a digital marketing expert at Zero Density, and I have Umut with me today, who is the sales executive in Zero Density. Well, our first guest is Mo-sys, and we will talk about tracking, basically. So let's welcome Michael and Martin from Mo-sys. Hi, Michael.
Hello, everybody. Hello, Zero Density. A real pleasure to be with you guys again.
Thank you for joining us. So let's talk a little bit about Mo-sys.
Mo-sys has a history in robotics and tracking and virtual production. So we started off with very, very precise camera remote heads that had zero backlash. That is required in the old days for motion control. So if you have one scene with Harry Potter and the other one where he was but is not him in, and you have to move that twice or several times exactly in a precise way without any jitter on a massive cinema screen. And that's where we come from, very, very high precision robotics. Today, most of that stuff is done in post-production, or like we see now with Zero Density, actually in real time. But still, we kept that our strength as sort of zero backlash, high precision motor drive gears. And then we went into tracking, where we had a lot of encoders on cranes and all of that, until we thought, oh, there must be something much better. And there must be something that sets people free and they can focus on their creativity rather than adjusting encoders on cranes. And that's how we came up, I think about 10 years ago, with a StarTracker. And it really revolutionized the tracking. And together with the zero density system, it sort of freed creativity and ways to do so. So it really, really made things much simpler. It made tracking simpler. You set it up, StarTracker, in a studio, and after that you can just switch it on anywhere in the studio. It just works. You don't need a special technician to sort of follow it and tweak it or do whatever. It's just you switch it on as you switch on a lamp. It just works. And that was a breakthrough, and that was the first time that was actually possible.
Yeah, thank you. So before moving on to getting to know StarTracker, I want to talk a bit about Mo-sys and Zero Density relationship. So actually, the first tracking equipment that the Zero Density research and development team acquired was Mo-sys in February 2016. And well, basically a few months later, we attended CAPSAT with Mo-sys tracking system StarTracker and also NAB. And 2017, we did the first project with Group Media TFO, the Louvre Studios, which got 2 IBC Innovation Awards the next year. And 2018, we moved on with Eurosport Winter Olympics, and after that, studio experience at SIGGRAPH. Well, we will talk about these projects briefly in the upcoming times. But 2019, we had the Mo-sys lens calibration at Dock 10. Star India, First Responders Live, Ziggo Sport, IBC Esports Showcase, and another studio experience booth at NAB. And finally, this year, there is Armenia TV and the Weather Channel. So, should we move on to StarTracker?
Birim, you forgot one.
Which one?
One other thing where we were first. Or it's maybe we just implemented. Basically, we implemented with you the first StarTracker inside a Cross Valley. And during this webinar, we actually want to show everybody how that is field upgradable. I think that's implemented with Star. Maybe it's not on your list yet because it's actually just happening right now.
Okay, let's let's see that soon. Great, but do you want to do StarTracker first, or do you want to show the grass valley first?
We do the StarTracker. First the principle, and then we show you the integration in the Grass Valley.
Okay.
Okay, so let's tell you a bit about the StarTracker. So the great thing about the StarTracker, it's an optical tracking system that consists of a sensor unit. So you have your sensors in here. This is attached rigidly to your broadcast camera, and it stays with your broadcast camera. And then you have a processor unit where all the intelligence is done. This is at the camera as well. And this means this is it. You don't need a server in a server room to do tracking or anything like that. Everything's at the camera. And so for each camera you want to track, you would have a StarTracker unit, and they work independently. So there's no single point of failure, for instance. And the way you mount your processor unit is this is all designed in the context of the broadcast industry. So of course, to make this unobtrusive to work with, it mounts as a kind of sandwich, very rigid and robust camera, so it won't fail on you. So you mount your camera plate onto here, and then this mounts onto here, and you mount your, you've got your camera plate and if there's any support like a steady cam on here, that clamps together. So you've got your camera on here, and then there's a short cable that attaches this onto generally the top of your camera, but you've got great flexibility in where you want to have that. So you could do it on cranes and things like that. The principle of the system, as Mikhail said, it was designed for the broadcast industry about 10 years ago, and we've been maturing it since then. You've got your tracking camera, and what we're going to do is we decided to get the robustness of an optical tracking system. We would take that and we would choose what features we're going to track. So we decided the studio space is very cluttered, and there's all sorts of things going on. You can have lighting changes shining down at you. You've got set pieces moving, people moving. To prevent the system being confused and to make it very robust and resilient, we choose to track off these little stickers, which we call stars. So to set up, you simply take these. They're cheap and simple. They're just retroreflective stickers like you'd have on ambulances, for instance. And you just take one of those and you just stick it to features that are stationary on your ceiling, on the walls, you know, above your grid. They don't have to be below the cameras. They don't have to be on the same height. You really have great flexibility in placing them. So they will mold to your studio, and of course, they won't be obtrusive. It's not going to affect your lighting people. It's not going to affect your set design. And then we have a light ring.
They can come in different colors?
They can come in different colors. You could mount them even on the floor. So for instance, we have black ones that you put on a black floor, and then you can use those with the sensor unit pointing down at the floor. And that's of course also good, for instance, for outdoors, which we've tested. And that's a really nice use case for downward facing StarTracker. So the way the sensor unit works is you've got your optical camera, and this is tracking these stars. That's all it's looking at. And you've got an LED ring, which means it's immune to lighting, the ambient lighting. It's not relying on that, which means your studio conditions can change. You can have strong lights, no lights. It will still work. The system's unaffected by it, which is, of course, what you need from a system that's designed for this use case. And so the system basically uses the kind of principles that of the way you track from the stars in the old days of sailors. And that means we can very accurately, in real time and precisely, find the position of the sensor unit in pan, tilt, roll, and XYZ, so all the degrees of freedom. And then, of course, to encode your lenses, we support both digital inputs from the lenses that support them and mechanical external encoders in zoom in focus. And of course, as we alluded to earlier, for the first time in zero density, we had lens distortion data being given out by the StarTracker. And that involves simply loading a lens file onto the StarTracker, and then it gives it out. So everything is basically taken care of in one place. And so what do you do? So the calibration process is very simple, easy to do, and works in pretty much any size studios. If you have taller ceilings, you're going to use slightly larger stickers and space them further apart. But once you've done that, what you do is there's a short calibration process where you walk around with the StarTracker sensor unit, and it automatically kind of triangulates the position of the stars in space to build a kind of star map. And then from then on, it automatically begins tracking when you turn it on. It finds where it is by basically tracking the constellation of the stars. And so the great thing about it is once you've set it up and you've got your star map, you don't need to operate it. You don't even have to turn it on. When it receives power, it turns on automatically, loads the star map and starts tracking. Our customers, most of them forget that it's there, which is really nice. It's just there silently doing its job. So that's really nice. So with that system, of course, this gave us, and it gives the customers freedom of movement. You can use any support. We have people using this on large cranes, on jibs. You can go handheld, steady cam, point upwards, point downwards. It really doesn't constrain the users, which is very important. And it doesn't need daily homing. It's just one-time calibration, and from then on, that's it. And of course, it's fully absolute, so it always knows where it is. It gives you your absolute position in meters and your angles in degrees. So it's really a very robust, flexible, really nice system that works in most scenarios where you can stick stickers up. I think it'll be nice to give a demonstration of
Shall we do
StarTracker
first, because we're now here in the control room, and then we show you how it sort of works in the studio. But then we squeezed all of this into the Grass Valley camera, which wasn't easy. And to be honest, it took us a couple of years, and I think altogether about 4 generations of electronics. But we did manage at the end. But the cool thing is this is field upgradable to the newest Grass Valley cameras. Abbas, do you want to have a go and basically take this apart? And if I put this here, maybe it's easier to see. So these are the components.
So this is the main lid for the Grass Valley. So we just take the main. This will replace
this whole box.
This box. Yeah. So that will replace that box. So and
I will just go in there. So this is possible to field upgrade.
And that will be the lid. So the processor will be on the side panel, and that just clicks in.
And that's it. So I don't know how long that took, but it's definitely faster than developing it in the first place. Yeah, so we have our own custom lid for the Grass Valley, and we just exchange them, and that can be handled in the field. And our first customer for that, together with Zero Density, is Star in India. What else should they choose? Star needs to have StarTrackers, of course. Thanks.
Yeah.
Cool. Now let's have a look in the studio.
So let's see. So I think we've got Olix joining us in the studio. Here he is. Lovely. So Olix here has a StarTracker mounted onto a Blackmagic design camera. So you can see the sensor unit connected to the processor unit there. And on the top right of this, you can see what the StarTracker can see. So you can see this constellation of stickers that we've stuck on the ceiling. And we built a star map and we're tracking with that. So the first thing Olix is going to show you is robustness to moving objects. So you can see, for instance, if it's mounted on a crane, you may have
Can you see Olix? Have you? Yeah.
Here it is. Brilliant. Cool. So you can see optical goods. So Olix is modeling what would happen if you have occlusion. So something like a low-hanging light or a set piece or something covers part of the tracking camera. Because it's a wide field of view camera, as long as it can still see some of these dots, because they're small and they don't have any markers or anything, they can, the system has a high chance of being able to see them through set pieces and things. And you only need to see around 11 or so to be able to track. And the next thing he's showing you is, of course, very strong lights being used in broadcast and film. And you can see this is something like a 800 watt floodlight, maybe a kilowatt, and it doesn't even pick it up. And if this were a halogen, it would be the same effect. It's a wide field of view camera, so it's got a good chance of seeing things of seeing some stars through whatever's happening in the foreground, and still tracking. So the next thing Olix is going to show you is the freedom of movement. So here Olix is going to keep tilting the camera down. Let's say you're taking a shot of something on the ground quite close. Let's see how far can you tilt, Olix? Optical good, it's still tracking. 45 degrees, and he's going to keep going, I guess. You can see we're starting to only have stars in the top part, but it's still tracking. Still tracking. So Olix is getting quite close to 80, 90 degrees, and only now is it starting to flag that it's starting to run out of stars. So you can go quite far down, and of course the gyro in the system will mean you'll still have your pan, tilt and roll for some time, even if you do lose tracking. And of course, as soon as you tilt up again, or if you cover the sensor and move, then the system immediately finds where it is once you can see the sky again. Here he goes, and then optical good. So it's recognized the constellation, it's recognized where it is. And of course, that's all possible thanks to this random constellation, this kind of star map of small stickers in the studio space. There we are, excellent. So that's the StarTracker.
Well, thank you. So, well, we heard a lot about StarTracker now, and we know it's integrated with Rodensity. So we are going to Umut now, so he will see how this integration takes place inside reality.
Hello, everyone. This is Umut. So thank you for the introduction, Brim. So I'm the sales executive now. I'm point out actually how the integration is done with Mo-sys and zero density system, because you may actually know that there are the key points for the systems, that how they're flexible in each other to integrate on the site. So, and in the screen behind me, actually we are in the virtual studio right now. So in the screen, in the video wall behind me, actually I'm sharing my display, which I'm now manipulating the reality interface, the R graph, which we can actually say all the management and the setup tool. So my friend can go a little bit in zoom on the frame, then you will see better. As you may know, zero density and the reality system is node-based compositor. So that's why the picture that you're now seeing here, it's whole the workflow of our system. So everything in our system, as you know, maybe like a nodes. So everything represented as nodes, like video inputs, like tracking inputs, like keys, like video flows, and everything are the nodes here, as you can see. So, and as we are now doing the presentation of the tracking, I can show you a little bit more deeper the node, which we call tracking node. And this node is Mo-sys, representing Mo-sys here. So the tracking data coming over the tracking input to the PC, where we are now, we can go a little bit even more zoom in. We can go more zoom. If we can't go, then let me just do, over here. So you'll be able to see better. Okay, so here, as you can see, that's the node, and the left part, there are parameters that we are reading now. And these parameters that we can reading and seeing actually can we just a little bit pen left part? Yes. And these parameters that actually what we're seeing here, the data, the tracking data, and all the inputs and the FOVs, the lens, let's say K1, K2 distortion levels, focus, zoom, and focal distance, center shifts, and we have all the things that we need that's coming from the tracking data. So, but what the good thing is, the integration is actually quite simple. It's like just a plug and play. So we just, put our UDP port or the Ethernet adapter where the tracking data coming, and then that's it. We get the tracking data with the calibration files from the Mo-sys. And so we can have tracking, delayed fields where you can apply some delays to match the tracking, and you can negate the space, or you can even apply or invert some in zoom and focus. You can even override or add more, let's say, offsets, let's say, on the camera here, So on the tracking, so you can offset your tracking data as well. But I want to point out actually more going deeper, like you may want to manipulate the tracking data. Why you may want to manipulate tracking data? Tracking data is tracking data. So what you would expect from the tracking data, track your camera and the lens. So which you may need to manipulate the virtual studio. But manipulate the tracking data, if you can access all the data individually in the tracking protocol, that gives you a great flexibility. Then you can go quite high level of a creation. So I will show you again the node behind me, as you see, and I can get some specific tracking, let's say, data as outputs. Like for example, let's go with focal distance here. So the tracking data sends me a focal distance, and this focal distance I can get as an, let's say, another as an output, as individual outputs. It's separated, and it just gives me the depth of field data as a matrix as only. So I can show you a very simple example how I can use this, for example, depth of field. You can get this data separately, so which means you can track the depth of field in metrics of the camera, of the lens. So that's why you may want to use those data for many reasons. Like, let's do a really, let's say, simple example. I will just create, let's say, a dummy cube, what we call it's just a 3D cube. Let's say, okay. So here, this is just a simple cube. So what I'll do, let's check the cube. Can we zoom out a bit and let's see the cube?
We have a cube in the house.
Yes, let's find the cube where we just put it. I just want to see, okay, here it is. So here is my cube that I just placed. So what I want to do is, I want to feed the transformation data of the cube with a depth of field, for example. The data that I'm reading from tracking from the Mo-sys. So like, which protocol that I want, for example, X. The transformation value of X I want to manipulate with depth of field. So I can just sign as a transform as an input, but I need to have another node to just break the transform. Let's say, okay, so probably make transform. So make transform gives me other data that I can get, like position. So I need to make again position, which we can also say that the let's say vector. So here now I'll get the X data, X parameter of the vector from the depth of field, and you'll see maybe there will be a jump on the cube. But now my friend will change the focus slightly in the camera manually, and you'll see that actually how we can get the depth of field numeric data and just parse into the graphics to do, you can change more and people see how the cube moves along the depth of field. Let me just change, for example, Y data this time instead of X. Just a second. Okay, now I'm feeding with Y of the cube. Now the cube will be able to move in the Y-axis. Let me just bring it back somewhere. Can we change the focus again? Yes. You can do faster even. Just see the whole move. Yeah, so you can see how it moves. This is just a one single example. So which means you can get all the parameters individually. It's like this was just the depth, the focal distance. So, but you can get the distortions, field of view even. So for example, we have another pipeline or just for example, fancy solution for the clear improvement for wide shots and close-ups. Like for example, when your camera goes more zoom in, you may want to get more clear details. So, but we can make, or when you go zoom out, you may need to soften the clear details in order to avoid, let's say, very sharp or let's say some artifacts in the white shots. So that's why you can feed the system how much zoom that the camera has. And then we can manipulate the key parameters along that. So like, for example, we have a node here which we created we call it a soft keyer FOV softness, and it has a FOV input. I take this FOV input and get the FOV separately from Mo-sys, and which is here, and that represents the angle. So I feed the keyer softness parameter, and I take the softness out as an output, and here is my keyer. Sorry, let me just make it. So I have a keyer here. Let me take it a little bit close by. And okay, so, and I just make my keyer's softness input as output. As an input, and I feed the FOV softness output with relative keyer. Now, whenever the camera zooms in and zooms out, now we are feeding the softness of the keyer. So which means in the far shots, you can have more soft details, which you may want to, as I said, because you may want to avoid these very sharp details in the wide shot, which may cause some artifacts. But when we go zoom in to the details, now you will have much more sharpened details. So this is how actually the system can automate it along to the tracking data that we can read. So in terms of integration, as I said, it's just a plug and play system. We can just simply, we can change the focus a bit. We can simply just plug the cables to the system and just define the protocol that, the port number that we just getting the data, and the system just work. So there is not a really complex setups in tracking in terms of integration, but actually on the other hand, you can have full flexibility to access each individual data in tracking protocol and feed your system with these data and do your crazy magics. So that's from my part.
Yes, thank you, Umut. Actually, before the registration part, we asked our attendees questions that have you done virtual production with tracking, yes and no? And the numbers tell us that 35% of our attendees right now haven't done virtual production with tracking. So don't hesitate to ask a lot of questions. We'll try to cover the basics with Michael and Martin, but just keep the questions coming. So since it's a relevant topic, I want to take a few questions, Michael, if it's okay for you. What is the maximum ceiling height that the StarTracker can be used? If there is no ceiling, what do you do? By the way, you're mute. Can you unmute yourself? Thank you.
That should be better.
Yeah.
Okay. Martin?
I think one of the largest or highest ceilings, I think what was called the largest studio in Europe, we actually did with yourselves for a show, which I think we have a slide on that in the future. And I think that was something like 16 meters high.
It's not 18 actually. It
was 18. It's something like 18. It's very high. They needed to use one of those kind of really heavyweight cherry pickers to actually go up there and move lights and things. It was substantial, really a hanger. You could probably fit a jumbo jet in there quite easily, maybe two. So the key thing is, so we've tested to something like that. The higher you go, of course, the larger you want the stickers to be because there's a larger space. And it does help also with the high ceilings to have the stickers at different heights. That helps a lot because then you get your parallax, which kind of helps the tracking. So that's the main thing. We don't put a hard limit in terms of the height, but of course there's going to be a point where you're going to have just from height either too much noise, for instance, just because it's in optical systems that the kind of noise scales with the distance. But yeah, we've done it in studios of that size. In terms of being able to track when you don't have a ceiling, so one way is of course to put the stickers on the ground. So you could, for instance, have a vinyl carpet, or we've even tested on those false astroturf material for pitch side interviews, and you stick stickers on there, and it's actually surprisingly robust to that. And so we have people who, for instance, would put it on vinyl, then they roll up the vinyl and they can travel with it. And then they go to a new location, roll out the vinyl, switch on the system, and then it tracks from that space. Another possible thing to do is to, for instance, hang up a net, which we tend to do on trade shows. And so that's use a very lightweight, thin kind of butterfly, anti-butterfly kind of mesh net that you put on plants. And you just stick the stickers up to that. And then it can track off that. Several possibilities.
Okay, thank you. So should we move on with our projects? And in the meantime, the questions can keep coming. So this is from CapSat, isn't it, in 2016? So it was the first time, actually, first demo of Reality Engine. It is launched at CapSat in 2016, and we did this demo with Mo-sys. So how was it for you, Michael?
I do remember that show. It was great, and you had your outing, and you just were testing the market. And we had another stunt somewhere, and I remember somebody coming and said, "Whoa, something really, really new happened there. Those guys are just using a game engine," and which helped in two things. Number one, you had photorealistic background suddenly, which didn't exist in that way before. But the other thing is that you have many, many more artists that can deal with it, rather than people that are dedicated, specialized on particular render engines and really sought after and difficult to get people. And that these two things changed virtual studios altogether. And of course, adding StarTracker to that.
So after actually CapSat, according to what I heard from the team, it provided a jaw-dropping experience for the audience, and then we decided to go to NAB in the United States. So it gave us a big confidence that the industry is very positive and they liked what they saw, and that's how the actually journey started. So it's good to have you from day one. And let's move on to actually your visit to our HQ. And well, this is Robert and Martin with our VP of Sales and Marketing, Ulaş Kaçmaz. Yeah, so you tested, you installed your system, and Zero Density's Reality Engine became the first engine to integrate lens calibration method. Yeah,
you can see it in the background behind Rob's red shirt. There's sort of a vertical stick of LEDs, and we sort of came up with that method because while others calibrate to a big sheet of A4 paper, which is a rather large target or sample, we thought there must be something smaller. And an LED is just like a millimeter by a millimeter. It's really, really, really small, but it's so small you don't see it anymore. So, but because it's lit, you can see it. And because there are these strips where many, many of these are in one row, we developed quite complicated algorithms so that we're only needing to pan. We don't need to tilt, and just pan across LED strips, one very close, one mid, and one far away. And that gives us all the information about the lens, including nodal points and everything. And an average zoom lens gets calibrated this way with between 1 and 2 million sample points. So you can imagine it's super, super accurate. And we have really honed and improved that version by now. I think, when was this? When did you get out there? Let's see, it's 2 years ago.
Yeah, around this January time, 2 years ago maybe.
Yeah. So that has since then massively improved, and we sort of split it now into two phases. Number one is, and we do this more and more actually in our office, so that we calibrate a particular lens or a type of lens, and then the customer just uses another tweaking tool that we provide, so you don't need to set up all these LEDs. We do that in the first place, so our library is growing of those lenses, and you just end up only to tweak. But what we have achieved is a procedure. And before, lens calibration was a tedious process that, or actually not a process, it really depended a lot on somebody's A, patience, and B, experience. And the lens calibration resulted differently depending on how much patience that person has and what experience that person has. So we then restructured that and brought it into a procedure. So now it doesn't matter who is doing it, it will have the same outcome. And that is really, really important for scaling. And virtual production is getting so much more popular. And it was in the past very often the lens calibration that was holding things back or causing political turmoil, because if the lens calibration is not right, you will see virtual elements drifting against the background. And then everybody will say, oh, it's the tracking. It's not. It's the lens calibration. And since then, we're actually taking the lens calibration and the tracking and our responsibility. The moment something drifts, call us, rather than getting caught in between. Is it engine? Is it tracking? Is it this? So I think we really, really improved the accuracy of the lens calibration, and secondly, we do take responsibility for drifting graphics, and we can because we do both sides.
I think removing the kind of dark art, as it were, from both the lens calibration and from the tracking is a very important thing. I think when we started many years ago, it was both in the setup of tracking systems and in calibration, everybody was just sending in like experts, people with experience who you'd hope would be on a good day, and they would basically be tweaking and guessing their way around to eventually try to set up everything and get good results. And of course, so we aim to make it a deterministic kind of non-human element in both the setup of StarTracker and in our other things, and in the lens calibration, which is why we've had this innovative way of doing it.
Okay, thank you. Actually, it is a question that we took. So, of course, lens calibration made a lot easier. So, how would you rate, like as in days? How long does it take to install StarTracker and do the lens calibration? Just approximately.
I think everything is geared for it, and it's I don't know.
I think for us, for instance, setting up the StarTracker, the thing that takes the most time is sticking up the stickers. Actually, that's probably the most kind of, just because either you can get a long fishing pole and just stick the stickers on the end, and lots of people just quickly like pop that up that way, or just stick on a ladder. Or here, actually, in your office, we stuck them on the floor, and I hope they're maybe still there. Or
yeah, it's actually next to my desk, so we still have them.
Brilliant. Hopefully, it makes for a nice Christmas party also. But there you can see we've got the StarTracker pointing at an angle there on the camera. But let's say, so literally, so with the StarTracker, you've got the mapping process, which is literally walk around. So in that space, which was, I don't know, 2 by 2 meters, that took a few seconds, I don't know, 20 seconds. To register, we have to register the tracking and verify whether tracking's okay. We have an automated method we call auto aligner, where you just point the broadcast camera center at 3 known points you measure out, and we have a special tape measure based tool for that. And then you press some buttons, enter those points, click calibrate, and it finds out the offsets and the kind of map offsets to align the map and the camera to the world. And that works. That makes things very fast. So that kind of thing, depending on how many coffee breaks you take, and I was very happy to take many when I visited you guys, because you have some wonderful Turkish coffee, which I finally finished in February, I think, during COVID. But with frequent breaks, I don't know, it could take, I'd say less than an hour. So that's very conservative to, set up the system, and it's very straightforward. It's a very straightforward one.
We can talk on the certain projects. Well, I agree, it's a difficult question to answer in just a few numbers. So would you prefer going through the projects and maybe talk in their specifications?
That could be good.
Yeah, Michael, do you want to continue on the...
And that is Hilversum NEP. It's a pretty big studio, and that picture looks really, really nice. But what is not in the picture is I think they had pedestals, they had a handheld camera, and there was a crane, a telescopic crane, and the studio was this the one where you're talking 18 meters?
This is a smaller
This is a
studio,
smaller
I
one.
think. There's
Yeah,
actually
yeah.
a smaller one. So they've set up, I think they've maybe set up 3 or 4 of their studios, all of a similar size, some larger than this, to have these stickers on the ceiling, and they become very kind of, you know, comfortable and happy with doing that.
I think they have now 16 StarTrackers. Yeah.
I think so. In most cases.
How many? Can you repeat?
I think 16.
Wow,
And they're doing
okay.
really cool stuff.
Yeah.
Okay. So there are questions rushing in, and when I want to take some of them as we move along. For example, what is your sticker material, and how does it work on black on black?
Black on black. I don't know. It is. Well, we researched a lot of different materials, and there's one we ended up with and being quite good, but because they differ in the angular reflectivity and stuff like that. And I mean, these ones are silver. We have some white ones. There's some black ones. You get them in any color. If you have a special request, come to us. We can help. And we got some see-through ones as well.
So white ones are the ones that reflect the most. So they are the ones.
There's a trade-off, isn't there?
Exactly. But if you're, you know, for instance, if you have them on the floor and they're black, then, you know, it's such a small distance that it's fine. But of course, for say a 16-meter high ceiling, of course, you're going to want the silver ones.
And they're going to be out of shot anyway. So yeah.
Yeah. Out of shot. So
I mean, because they're stuck on from underneath, they never get dirty or dusty or whatever. It's.
Yeah.
If you go to the BBC, there's a 16-meter. Which stage is this?
Studio D.
The Studio D is quite tall, and it doesn't matter how they have.
Been there for years.
They have been there for years. I mean, that's where the whole thing started, and it doesn't matter how they change the light or their set or whatever. You just go in there, you load the map of that particular studio, and bang, you're there.
I mean, this is a material that was, the glue and the material itself was designed for things like you put them on police cars and ambulances. So it's material that's kind of, you don't have to worry about it being a sort of temporary thing that's going to fall off, as it were. It gets, you know, once it's stuck on, it's going to stay stuck, because, you know, things like this is designed to stay stuck through rain and so on. So it's not something you have to worry about it kind of falling off, for instance.
Are you suggesting to peel them off police cars?
If one, actually, so any color you'd find on a police car, you could in principle have. So it's a similar material, but the key thing, which I'm not sure if police car material actually has, is that, and also for the road signs, is they tend to be kind of optimized for a certain kind of head-on view, or because you're never really going to see a police car, for instance, kind of upside down or at a 45-degree angle. They generally stay upright. They're designed so that they maximize the retroreflectivity there. Whereas with our material, the key thing is that whatever kind of angle you're seeing it from, I can like pan this around and I'm going to get the same level of retroreflectivity. So it's not going to be if you turn it at 90 degrees, then you have a low reflection or and so on. It's the uniform type material.
And how much bandwidth do you need to feed the graphic engine?
I think it's like, is it 50 kilobits?
It's something like that. So It's
very
quite
little.
low. I think it's less than 100. So I guess the relevant one, the relevant numbers are maybe people wondering, do they need a gigabit link, for instance, or can they get by with, say, 100 megabit? And I think it would be considered a relatively low bandwidth connection in terms of its needs, because it's just, yeah, something like 50 bytes or so, and maybe 80 bytes at most going through every
Per frame.
per frame. So it's 100 megabits should be more than enough.
Okay, perfect. And well, what's the requirement on lenses?
The main thing is that you have a physical end stop for the zoom and the focus, that they do stop, because or that they have an internal serial connection. Yeah.
Okay.
They are autofocus lenses that basically you keep on turning them, and there's no limit. They're sort of more tricky or difficult. I mean, there are ways of doing it, but it's not something you want to be relying on, because it could just be a mismatch and then suddenly your whole show is out. I would not recommend autofocus lenses where basically the lens ring keeps spinning.
Okay, thank you. Let's move on with the projects. I was moving on my own. So the one I'm showing right now is NEP Zone Studios, and you already talked about what NEP has in its studios: 16 StarTrackers, and they have quite a lot of reality engines as well. Zero density. Well, NEP Zero Density is strategic partner, well, since 2016 as well. And this is another of their productions, Winter Olympics. Do you have any details you want to share, or should I continue?
Just the word Olympics inspires, because we just missed one because of COVID.
This was a cool one. I visited that studio, and this wasn't actually done in their studio. They just converted a sort of space in the foyer into.
They call this coffee room.
Sorry,
wasn't that on?
They call this coffee corner studio.
Cool, exactly. So I guess the general populace has had to go somewhere else to find coffee. They found pedestals where they had coffee machines previously, but it was very cool what they did. They're really kind of cool at putting up things like truss structures, and they made this lovely wooden thing for stickers. It really looked very nice when we were there.
There's also another question. What we have here today as project examples are indoor. So one of our attendees is asking, what are the requirements for tracking systems when it's outdoor, when it's indoors? Can you specify?
I don't know what to say to requirements, but I would not look for a tracking system that does both indoors and outdoors. It's really different worlds, and you end up with compromises if you take that. There are certain systems that are really good outdoors. They don't need any stars and stuff like that. They are a compromise indoors. And StarTracker equally, I think it's the most robust and easy to set up system indoors. If you take it outdoors, it is starting to be a compromise. So you have to start moving around your technology creatively. I mean, like you were saying, you can use a carpet. It works fine, but you're not really free. If that helps you, great. Well, StarTracker in the studio, you don't need to consider it. It just works pretty much whatever you do. You don't need to work around the technology. And there's other technology that you can use outdoors. We don't do them. But for example, NCAM or something, and they're just bloody good outdoors.
And of course,
may I ask a question? So to you, Martin and Michael. So this is it might be another question that the viewers can remind. Like I was thinking if it is possible, considering outdoor, if we can, let's say, have a kind of a textile carpet or a kind of a fabric carpet where the stickers on it, and then it's just rolled, and it would be a sense that if I can take that carpet and open on the ground and put my camera with the Mo-sys, the head down, and do my tracking. Does it make sense?
That works really, really well. So, like Martin was describing, you put those on those stickers on a carpet. The nice thing is as well, you will have mapped that carpet,
Correct.
your workshop, studio, wherever you are. When you go to location, you just roll it out, you switch it on, bang it. So there, you don't need to map anything. You just roll it out and you can start filming.
So the only thing that actually we need to take care of, if the surface is rough or just flat, is that correct? That where
Yeah. If you have undulations in that, yes, you should remap, which takes a second. I mean, we have, and we're getting to that point later, a lot of other tracking technology. I think we're the company with the sort of broadest portfolio on tracking technology, optical, mechanical, and lots of other things. But I think we get to that later on. I mean, outdoors, you can use a crane with encoders. You can use, we just had a webinar on basically for virtual audience using our V70 kit. So these are kits that you clip on within minutes onto the most popular camera head, which is the Vinton Vector 7 series. So there are lots of other possibilities as well, apart from StarTracker, but I think we will get to that.
Okay.
So moving on with another project. This is actually from IBC, right? It was a esports showcase that took place inside the auditorium, and ESL had a live broadcast inside a very small studio, and they were inside the map, basically. Do you want to add anything to this project about the tech tracking requirements?
I think I went there once to visit. Basically, they use the StarTracker autonomously, so they don't need any kind of a support or anything from us. So a lot of the projects they're using it on, we don't actually know many details for, which is of course good, because they're of course we want our systems to be so easy to use that people just get going themselves, and that's a good sign. So that's what they had. I think I came round to see it, and it was again on an auditorium, I think. No, sorry, I think it was a foyer space. So that would be what we would consider on a smaller end. So NEP are actually users of extremes, so they're quite good to be using our StarTracker. So they've used them in the larger studios and the smaller studios, and there's not really any difference for them when they use them, which is nice. They just get a stable, good they get a stable experience. And I think one good thing with NEP as well is, which we try to have, is we want our customers to kind of, when they use our system, they kind of get a sense of it. They can be intimate with the system. It's not a system that we keep customers at arm's kind of reach from. It's not a system where they need to call us to do everything. We try to empower the customers who use our system so they understand what it's doing. They can use it as power users if they want to, and I think, or they can use it as kind of, in a simple way, if that makes sense. We're not going to block customers from being able to extract the full power of the system, and I think NEP are kind of become power users of the system, which is really nice, and so they can do really cool things, and we periodically have been there to see what they get up to, and it's always amazing to see, to realize you see the system, they're still tracking there exactly from the day they started, and of course we go there and we're like, wow, these are so old, but they're still tracking like the day when they switched on, which is really cool. So that's really nice there.
So I keep showing the projects and take questions in the meantime. So one question asks, how does the tracking work if you have an uneven floor? Does this affect the tracking performance?
No, it doesn't. So you can have steps. I mean, we have studios that have different levels. Different levels in the sort of like mezzanine floors, but also on the ground. It doesn't
So,
matter.
for instance, if you have steps going up
Yes,
to a
that's
stage,
no
for
problem.
instance, you can stick them on the stage and, sorry, on the steps going up, and it's not a problem because, of course, it's mapping them out in 3D space. It considers them in 3D space, so it's not a problem there.
Yeah. Okay. And maybe this goes as a technical question, but how does the tracking sensor communicate with the sticker? This is one of the questions, and yeah.
It sees them.
Yeah.
Very straightforward.
Sees them. It's
So,
a camera.
Yeah, So the light ray goes from the LED ring around the camera and it bounces off, and the properties of the stickers are they reflect light in the direction from which it came, which means to everyone else they're very difficult to see. But to the sense unit, they suddenly kind of light up, and basically the light ray then pings back into the optical sensor of the StarTracker.
Like a traffic sign in the middle of the light when you're driving with a car, and the moment it hits the headlights of your car, that is suddenly shining back much stronger than the surrounding.
So there's no RFID or anything like that. There's no. They are just plain stickers.
Well, as Martin said, sometimes it's a relief that we don't know much about the project because it shows the client is autonomous and they can work the product on their own. But yeah, Weather Channel is a project that we are intimately involved and very, very excited to have this going on. And it works with Mo-sys StarTracker as well. So do you want to add anything on this?
The Weather Channel was cool because I had friends in the US who kind of just separately, without me being involved, they came to me and were like, oh, by the way, we saw this thing on the Weather Channel. Did you have any involvement in that? And I was like, that was really nice. Because then you can really see that what we do behind the scenes has a kind of impact that it's really material and it's out there for everyone to see. I'm sure maybe you guys have the same feeling. So that maybe something that you've implemented or something that you've sort of enabled, and then you kind of see that on your screen and you know that millions of people are seeing that. And I think even, so for us, we are specialists because we deal with this stuff every day. So for us, it's kind of, you cease to be surprised. You kind of lose you get this kind of critical eye or this kind of seen it all before kind of thing. Whereas it's sometimes nice through something like the Weather Channel when you see the graphics to realize from the perspective of a normal kind of person watching a TV, they're probably like blown away. They're kind of really impressed and they see the magic. So we see the kind of tech behind the magic, as it were, and we enable that, whereas the user like sees an amazing experience. And that's a really nice thing of, what's possible, I guess, when zero backlash meets zero density, I suppose.
But Weather Channel is a really good partner. I think they are pushing boundaries in a very playful way. They're just pushing forward. It's quite cool.
Yeah.
We're very, very proud of them as a customer.
Yeah, they're definitely leader in innovation in this area. That's for sure. So, okay, studio experience project. So this project also has an importance. It was the first Ultra HD Unreal-based virtual studio production made possible with Reality Engine and, of course, StarTracker. So you also have Via Dolly and RoboJib here.
The Via Dolly is basically a sort of rail-based system that allows you to curved rails, for example, and exactly in an interview situation like that. So you sort of travel around your interview situation and giving a really nice, smooth shift of perspective, and therefore you feel that you're in a 3D space. Yeah. I think we sold to Sky, and we must have done something right, because they immediately they bought another two. So, and the other thing we showed there together with you guys was the RoboJib, because we thought, well, in a way you would like to have two cameras, and it's on that NAB it was everything was sort of circular. The sofa was circular, the green screen was circular. So it would be nice to have two cameras equally circular. So you can't put them on the same rail because they bump into each other. So we thought, wow, why not have a robotic crane from the ceiling? And as you can see there, that's the beginning of what we call the robo jib. So there's a light version here that you can hang on the ceiling, and it will sort of also in a circular way travel around the center, while a little bit below was the via dolly, which also has a telescopic column going up and down.
Okay, thank you.
So showed on, yeah, okay. Yeah, and that's the Grass Valley integration of the StarTracker, which we demonstrated a little bit earlier on.
When did you operate at the Grass Valley for Star India?
It's still in process, to be honest. It was sort of held up a bit by COVID, but it is happening right now.
But yeah, they made the project Cricket 19, right? 2019 World Cup.
I think so, and that was the IPL in Premier League.
Yeah.
And actually they had, as far as I remember, 4 camera systems and all 4 Mo-sys tracking devices. So, and they have also really high seating, as far as I remember. So, but it correct. So, but the systems are perform perfectly. So, and that was one of the. I mean, actually, we can clearly say that was the best virtual production that is recently done in India in real time for sports.
Yeah, it's the biggest in the region, actually.
Correct.
Yeah.
So we started that off with normal StarTrackers, and in the meantime, and they're basically waiting for the implementation of the Grass Valley ones, but they're now ready to be implemented the moment they open up.
Yeah.
Cool.
Okay, so let's get to the questions. I don't want to keep them piling up. How much is the video delay on main output using tracking? And how do you transfer tracking data between camera and on Reality Engine more than 100 meters of distance? So how is distance an important thing in tracking, basically? The question is.
So you can choose on the StarTracker between 1 and 2 frames. We just brought out a new version specifically for LED wall filming that is a faster one and has just one frame, or less actually, delay. The distance is, oh God, how does the distance? You will add, we also have wireless transmission, but you will add 1 frame to that, through that. We also have a way now, that's also new actually, where we add the data into the audio side of the SD signal. So which means it always stays together. That is useful not only for wireless transmission, but also for just normally, if you do want to have the tracking data combined with the image, it's a good way to do that.
Okay.
And then we have, especially for sports, I wouldn't say in studios, but in sports, you can transmit with the Mo-sys bus, which reaches like 100 meters and it doesn't add any delay to the sensor. Then we have fiber that goes up to 20 kilometers, and I don't think you sense any delay there.
And of course, IP is, in principle, go as far as you like. It depends on your networking infrastructure.
Yeah, okay. Some of the questions are very long and it takes me time to read them, sorry. But I'm going to go for a shorter one. Could we place the stickers on the floor or on dolly track spreaders? What is the minimum distance required between the CCD and the stickers?
What's happening, so there's no minimum or maximum distance. If they go further away or the ceiling is taller, then you just make them bigger. And if they get closer, you make them smaller. The only thing is you start having to restrict your maximum speed of travel, because if a star is just above the lens, the StarTracker lens, you very quickly cross frame. While if it would be very, very far in 10 meters distance, that same sticker will not travel so fast through frame.
So we've had people use them on steady cams pointing at the floor. They've gone down to about 40 centimeters off the ground or something, as would be natural when you're, for instance, using a steady cam, and they've never reached those limits. You know, you're not going to have to be careful. You can move like naturally. Usually the restriction is that, of course, when you're broadcasting, you're not trying to like make people sick at home by moving your camera like all over the shop. So yeah, we don't really place a restriction. Of course, the closer you get, the more dense and smaller they should be. And that's the main thing.
Okay, thank you. So I have a question for Umut. There is this question: do you recommend individual engine per camera with the keying, or do you, well, basically use a switcher for that? What is the recommended setting in this?
Sure. I mean, in a professional infrastructure, of course, we do recommend per engine per camera. The reason is each engine actually takes the tracking data and rendering the graphics, and it gives as an output. And in a standard workflows or the broadcasting, so there are video mixers where the directors can just choose the picture and cut between cameras and do overlays and those. So the engines or the system, whatever, needs to fit in this workflow without any interaction or any change in that workflow. So as the workflow actually requires to being continuous. So that's why, of course, that should be like per engine per camera. But it doesn't mean that, I mean, you cannot use one single engine for multi-camera input and multi-camera output at the same time. So you can either get multi-camera input on single engine, you can do your cut or transitions in the engine, and you can get only the program and preview out from the single engine, or you can either get multi-camera outputs in one single engine. But the thing is, of course, when we just start to input the cameras on one single engine, that makes the system one point of failure. So if you lose the engine, you just lose the program. The other thing is, of course, the performance, because each camera actually means different rendering pipelines. So each camera inputs the system, the GPU just split in that number. So that's why you may not go that high resolutions, or you may not able to render particles or complex graphics in that case.
Also, can we say that since, for example, Reality Engine is compositing, doing everything, keying in one single system, you don't need to use a switcher and do the keying on an external machine?
No, or keyer, Reality Keyer is actually software-based keyer. I mean, so it's the software and running in the engine, I mean, in Reality Engine. So the keyer is not a separate device. It's running in one single PC, in the rendering PC, so we can call the Reality as actually channel in a box. So that's why, yes, you can get the camera inputs, doing key compositing, everything in one single PC, and get the program out, composite final out. Yeah.
Okay, thank you, Matt.
Welcome.
So back to videos, basically. Now we're going to talk about art. Is that correct, Michael?
Art. Okay.
Yes. There's some drawing skills here.
Yeah. Okay. StarTracker is, you can make it smaller, and you can use this as an object tracker, and it has a similar sort of performance and precision. And in this case, I think we did that also with Star. We did a StarTracker inside a spray can and did mid-air graffiti. Yeah. Equally, you can put the StarTracker into an object or into, I think we also have it on motion capture. Belty, you have these motion capture suits like the XN suit, and they're bloody good. They're really, really good. They're giving you the best performance. You don't need to clean up like with outside-in system, but they have one problem that they oh, thank you, Alex. Here's a belt. They have one problem that they don't, over time they forget where they are, because I mean, quite good actually. They calculate the position where you are in the studio in depending on your step length and your direction, but you can imagine after a few minutes that it doesn't know exactly where it is. So and that's where this device helps. It's a StarTracker, similar to what we put in a spray can. The performer can have that on the back or on the shoulder or wherever, and basically finds its position within the studio. And this way you can use these inertia suit to do different, to have multiple actors and performers. And you can actually use it across a massive stage. All you need to pay for is the stickers, to have more stickers, while there are other systems that make it pretty expensive, and therefore very often you keep your mocap area it's very often limited by your budget rather than creativity.
Yeah. Okay, so another question about lights. How lights, well, basically give us the ideal light setup for the stickers and the tracking data to work perfectly.
There isn't. I mean, that's the cool thing about StarTracker. We don't, and that's what StarTracker changed. Before there were other systems like the 3D, the BBC, which had these circular targets, and they were large, and you needed to be careful with your lighting, and you had to sort of design around it. I mean, that system was brilliant. I mean, for the time it was developed, absolutely impressive what they achieved. But then times moved on, and we were able to develop StarTracker. And that was the advantage of choosing those small stickers, that they are actually not large, and therefore you have plenty of them, and if you lose some, it doesn't matter either, because you have an abundance of those stickers, and that really helps.
Okay, thank you. So let's touch base on our final project, which is Armenia TV in 2020. I mean, the final project that we're talking on the webinar. Well, in our previous webinars, with the Panasonic webinar, we had a question that if the PTZ camera UE150 could work with Mo-sys. We answered yes back then, and here's a real-life example from Armenia TV. Right, Michael?
Yes. I mean, they're using the UE150 there, and what we have developed is a StarTracker for the UE150. UE150 from Panasonic is fantastic. I mean, it's a camera with integrated lens, a 20:1. It's a 4K camera. It's a remote head. It has built-in tracking. It's actually nearly all you want. The only thing is, as a pan and tilt head, it gives you like a 2D immersion or no immersion into the space you're in. It's just like panning around on a picture. You need a change of perspective to have a feeling of being in a 3D room. And what broadcasters try to do is get audience in their premises in a way, and you need the sense of a 3D space, and that you achieve only when you move the camera, not when you angle the camera. And this is why we added a special, you could call it a shoe. It just goes under the UE150 as a StarTracker in the front. And then now suddenly you can use it on a crane, you can carry it around if you want to, on rails or whatever. It's suddenly free, and it's quite a cost-efficient way to achieve everything. Alex, you're bringing all this. Oh no, you haven't got
doesn't have a StarTracker.
Okay.
I'm
We
looking
wanted
for
to
one
show
right
you
now.
one, but they're out at the moment. We're just building the next
Too much
batch.
demand.
But you can suddenly get a feeling for the space you're in, which you wouldn't get with just a pan and tilt head. Also, a pan and tilt head, you don't do creative moves. You basically reframe your anchor or your actor, and then you leave them steady if somebody is sitting, for example. So you cannot do creative moves that reveal the environment. Now, StarTracker, you can suddenly do that.
Yeah, thank you. So let's move on. While we discussed the projects, we took most of our questions. So let's take a look at a wider angle to Mo-sys, because you're doing actually a lot of products. So if you can give us a short overview of them.
Okay, let's race to the next slide, and I think it's easier to explain. And I know that this has been taking a long time now, and I try to be really, really fast. So first one, StarTracker, we explained that earlier. Integration into Grass Valley camera. We even demonstrated that, a field upgrade. The next one is the StarTracker UE150. We also explained that, but you see sort of at the bottom, on the very right, the StarTracker part of that. The new version now as well, you can as well reverse it. So it works upside down. And for the StarTracker UE150, the thing is, if you want to put it on a crane, you do want to operate it from the back end of the crane. And we actually have developed their input devices that that allow you to do that. And on top of that, you can still control it from your gantry through the normal Panasonic interfaces.
Yeah.
Good. Okay, now, object tracker. StarTracker is really, really popular. I don't know, we ship it now into 50 or plus countries and have it in many, many studios. It just becomes or became a standard in what you use for in-studio tracking. We also now have an OEM version that we are providing that to robotic manufacturers that have pedestals and things like that. So of those is, Telemetrics, Vinton, Shotoku, and many more thinking about it. So, so you have the StarTracker in that. It's a slightly lower cost and simpler version because you do have the pedestal around it, and the pedestal gives really, really good tracking in pan and tilt. So the gyros, for example, and other parts don't need to be as sophisticated as the normal StarTracker that you can freely roam around. But the combination of those pedestals and the remote head plus StarTracker gives you really good tracking, but also enables you to have absolute feedback for the robotics, and that didn't happen before. So if you can really over time constantly let that pedestal go back to the same space, and it will be always in the same space. It doesn't need to be rehomed or any of that stuff that was needed to be done before. Also, you can suddenly use them for AR. Some pedestals you were not able to use for AR because if you don't rehome all the time, they will drift. StarTracker stopped all that drift. So, Then there was can you just go back? I promise to be really quick. The e-sensor. The e-sensor is from Cartoni in a collaboration. Camera head, pan and tilt head, all the electronics, everything is built in, and there is no additional boxes or whatever outside needed. That's quite nice. Then we have on the very left bottom the V70 bolt-on kit, and that is a strategic decision to make a kit here because this is the most popular head that is in the field and provided by rental houses, and you don't want to upset them. So we just add that on. It takes you about 5 minutes. And the main thing is these are direct encoders. There's no gearing and no belt, and that is really important. Belts are something and gears are something. They need technicians, they need to be checked if they're right. Belts can be too tight, too loose. Well, this is a system that can easily be bolted on by a technical person, but it doesn't need to be one of us. And yeah, it takes about 5 minutes. In the middle is a picture of that, the control box. Yeah, and on the bottom right, there's the Jimmy Chick tracking kit. It's a kit you bolt it on. This one has the advantage, as well as like on the V70, it's all absolute and direct encoders. There's no gear. Gearing gives you, when you change direction, or can give you, a sort of lost motion.
Okay.
Encoded, motion encoded. What else is there? Oh, our remote heads. On the very left is the L40, which is primarily used in the film industry. It copes with any big lens. We're not using worm gear, so there is no jutter in there. It's really popular. Now, the U50 is something we just created during COVID times. It's based on the L40, but it's super, super rigid and strong to cope and handle the box lenses. And it can actually, you can yank a 30 meters distance fully zoomed in. We tested it with 1,600 millimeter with the extender on a Fuji 99. And you just yank from one space to another, foot distance at 30-meter distance, and it hard stops, and that thing just stops. Sadly, in the presentation we did, it did wobble a bit, but we figured that out and fixed that. So the B20 is primarily designed for the TV industry, as is more budget conscious, but we wanted to capture what all of our remote heads have, and that is zero backlash. And zero backlash allows you to have an imminent movement. You don't need to wait or ramp up so that you don't have some sort of jerk movie and try to hide it. And for that, we developed a special gear, which is our jam drive, and it's patented now. It's super quiet, no backlash, and it has a massive hole, a big hole in the middle where you can put cables through, no slip rings required. Was that it?
Yeah.
Okay. Okay. Oh, the robotics now. The robot chip, the one from the ceiling, a little bit lighter one, and on the right-hand side is the robot chip. That is fully robotized chip. We just prepared 2 of them for the Olympics. One was meant to be in Sweden, and the other one in Tokyo. And the setup was in a way that there's an interviewee and an interviewer on the same table, but actually in different countries. And the control signal from Europe would have a certain delay when getting to Tokyo, and we compensate both synchronized to the atomic clock, and they both really work at the same time. So we do a lot with remote control and time compensation. Another thing we did, and was just yesterday, tested by a 3-letter broadcaster, and I think they liked it. What we call time cam, and time cam allows you to control a camera on the other side of the world without perceived delay. So suddenly sports following, you can leave your cameraman in London and they can do a transmission in, let's say, Australia or Switzerland in the afternoon or whatever. So you don't, with COVID, suddenly becomes really, really a sort of key thing.
Okay, so what about the 3 different tracking data from a single camera? Is it possible, actually?
Yes, StarTracker is outputting, for example, to one render engine output Radamec, and to the other one a different protocol F4 at the same time.
So
okay,
3 destinations and broadcast as well.
Martin, do you want to repeat?
Yeah.
Just to add to what Mikhail said, each StarTracker can send to up to 3 destination IP addresses, and they can all be different protocols and broadcast as well.
Yeah. Okay, thank you. So can the tracking data be embedded into a source camera video and maintained with a time relation for future post corrections?
Yes. For example, we can embed it into the audio side of an SDI signal.
Okay. And the example would be if the ISOs are recorded along with tracking data, user freely modifies the changes the graphic layers or virtual objects.
Yeah. That
Yeah.
would be the result out of that. Yeah.
Okay, perfect. So the final, as the wrap up, actually one attendee wants to see the Mo-sys control and configuration interface.
So you can see here's this one has our Mo-sys lens data. So it has a lens one, it's giving out the actual lens parameters in our F4 as part of our F4 protocol. And of course it has its own IP, so we can connect to it and talk to them that way. And use, for instance, Bonjour to discover their IPs when we connect it to the network, for instance. And so the big numbers are the main ones. So the main thing you're interested here, to be honest, most people don't even look at the screen. Some people like to have it. And the main thing is you're seeing, are you getting your green optical good? And that's really...
Some remove it as well.
Yeah.
They don't want to distract the cameraman. That just, you need the display probably initially when you set it up, but the rest is just flick a switch and switch it on. You don't need anything, or you need to do nothing during operation.
Yeah,
at all.
this is basically, this interface isn't, you don't use it to operate the system. You just use it for things like commissioning or, you know, or if you're changing studios or something. And then, so this is more like a sort of, you know, a kind of engineering interface, just because it's not something you need to sort of use. You use it by just moving it around. And so you can see your, for instance, your tracking position.
Good.
Okay, well, this is all. Thank you, Michael and Martin. It was a really good start to our webinar series. I can say that for sure. Thank you so much for joining. It was very informative. We had a lot of questions that clarified the spots we have left. But thank you. Do you want to say something as a goodbye to our attendees?
Yeah, thank you.
Thank you. Thank you from the beginning, from CAPSA. Thank you.
Yes.
Till now. And it's great working with you guys.
Thank you.
Thank you so much.
Bye-bye.
Thank you, Michael.
Yeah.
Bye-bye.
Goodbye.
Bye-bye, Martin.
Well, maybe our people can take us from the virtual studio now. Let's see our green. Thank you.